in your white packet, if you wanted to pull it out of your binder today, that's fine, because we're going to be kind of flipping back and forth between it, but that's totally up to you as to how you do that, okay? But what I would like you to do is, on page number 2 in that binder, there is, there's 4 problems there called the retrieval problems. What I would like you to do is, and I'll give you a couple of minutes to do that, I would like you to do those 4 retrieval problems right now. Go. So, given 10 minus 3g, if g is 5, that means I'm going to plug 5 in for g. 3 times 5 is 15, so that's going to be 10 minus 15, so that's going to give me a negative 5 value right there for number 1. Yes? Thumbs up if we're good? Lots of thumbs, that's awesome. Okay? Same thing over here, except now instead of plugging in 5 for g, I'm plugging in 8 for x. 3 times 8 is 24. 24 divided by 4 is 6. 6. Oops, I got a little ahead of myself right there. I even put 6 there. 24 divided by 4 is 6. 6 minus 12 is negative 6. There should be our answer for that one. Thumbs. Yeah? Yeah, all good so far? Love it. Okay. Doing the same thing here in number 3, except now you're just doing it as a table. Instead of just doing it one time, you're using the same equation 4 different times. So this is going to be 3 times 0, then minus 5. This is going to be 3, This is going to be 3 times 1 minus 5. 3 times 2 minus 5. And 3 times 3 minus 5. 3 times 0 is 0. Minus 5 is negative 5. 3 times 1 is 3. Minus 5 is negative 2. 3 times 2 is 6. Minus 5 is positive 1. 3 times 3 is 9. Minus 5 is 4. There. Yes? Good on that one so far. Okay. Now, in my last class, and I'm sure you guys didn't do this because you guys seemed to me like you actually were paying attention to what the directions were. In my last class, they did this one a little bit goofy. Okay. It said graph the points from the table onto the graph. Well, we got to know that x is our horizontal and y is our vertical. And then these all graph out into different points. So this is the point 1, 16, which is way up here. This is the point 3, 13, which is right there. This is the point 5, 10, which is right there, and this is the point 7, 7. 7, right there. Yes? That's it. Did it say connect them? No. Did it say graph the line containing these points? No. It just said graph the points, so I just want to see those 4 dots. That's it. If you drew that line in, that's why we do things in pencil, so we can erase when we get them wrong. On a test, if this were a test or a quiz, and you connected those dots, I would mark it wrong. Okay? Because that's not what it told you to do. Okay? Questions on that stuff so far? Okay? We're going to jump into the title of today is Checkered Board Orders. Okay? So on page 2 now, you have a diagram that includes, it's a pattern of tiles made around a 5 by 5 square. So the 5 by 5 square that it's made around is right there. Okay? So that is the 5 by 5 square that is the border is made around. Okay? What I need your table to do is I need your table to come up with a method to count the colored tiles without physically counting the colored tiles. What I mean by that is I don't just want you to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and so on and so forth until you get that there's 28 total tiles. I already know that there's 28 total tiles. Okay? I want you to find me a pattern because the next group that you see at the bottom, now we're going to be around a 6 by 6 square. Okay? Right? So you at your table, take a couple of minutes here, come up with a pattern, a way of doing them. There is no wrong answer to this one. Okay? You're looking for a pattern, there's no wrong answer. What do we need to do though? We already told you that was 28. You were busy figuring out when I said it was 28. What do each table need to do though in order to accomplish this goal?
Work together.
We gotta talk. Yep, we gotta talk and we gotta work together. Okay? Go for it.
9 times 9 is 81. 5 times 5 is 5 minus.
Anybody willing to share their method? What do you got for me?
Well, I just counted the outside and the base. Well, I counted the height, the length, and the base.
Okay. With height, all the same thing. No.
I just did, so that was 9, so I did 9 times 9 because it's a square. And then I got 81 from that, and then I took the square, and it's on the inside, it's 5 times 5. And I just subtracted that off of 81, and because that was the total area of the square.
Okay.
And I got 56, so then I saw that every other hat is like shaded.
Okay.
So I just divided by 2.
Okay. So you went 9 times 9 minus 5 times 5, and then you divided that by 2. Because you got 9 here on the outside, you had 5 on the inside. Okay, all right, I like it. Anybody else use that same method? You guys did, you guys did, you guys did? My other 2 tables, what method did you use? Or did you not come up with a pattern? No? Didn't see one? Table 8? No? Nothing? Okay. Other patterns that were told today, or that I saw today, one group noticed that this was always a group of 4 down here. So they went 4 times 4. Because then that group of 4 was always on the outside edge. There was always 4 colored tiles on each side of the outside edge. And then they went the inside edge, there was 3. Okay? And that's how they got their pattern. Okay? I like if I take these 2 tiles out on every corner. Okay? Now, table 6 and table 8, you're going to have to use one of these 3 methods going forward here. So be paying extra attention here. Okay? Right? So I took those 4 out. And I knew that there was always going to be, or there was 8 tiles in there. Okay? And then I noticed that if I bring this colored tile down, and this one down, this one over, and this one over, this one up, and this one up, over and over, now they line that inner square. Right? So there's 4 of sides of that square, each with 5 in it. Okay? All 3 of those methods work. Okay? With me? All right. Now, plans change. now instead of it being a 5 by 5 square, now it's a 6 by 6 square. So using one of those methods, not just counting them, using one of those three methods, figure out how many colored squares the construction company needs in a 6 by 6 pattern here in the middle of the checkerboard. So now this is a 6 by 6. Okay. Using one of those three methods. Go. Should have gotten 32 colored squares. Okay. So if we did it the first method was, so now it's a 10 by 10 grid, and it's a 6 by 6 inside divided by 2. 10 squared is 100. 6 squared is 36. 100 minus 36 is 64. 64 divided by 2 is 32. Okay. If we do it the crazy, like counting on the outside method, then there's groups of 5 here. There's 1, 2, 3, 4, 5. 1, 2, 3, 4. Oops, nope. Hold on, tap the brakes. I gotta not take that group of 5. I gotta take this group of 5. Then I gotta take this group of 5. Then I gotta take this group of 5. So there's my 4 5s. And I still have 1, 2, 3, 4 groups of 3. 4 times 5 is 20. 4 times 3 is 12. 20 plus 12 is 32. Okay? Or, could have done it the way I like. Here's my 2. Here's my 2. There's my 2. There's my 2. So that's my plus 8. And then now I've got 6, that line here. Down, down, down. Over, over, over. There's my 6, that line there. 4 times 6 is 24 plus 8 is 32. Okay? Okay? What I need you to do now is, first off, this is not an accurate drawing. Okay? So you can't just count the squares here. The answer to this question is not 19. Okay? Alright, the answer is not 19. Okay? The answer now is, the company is doing a lot of these checkerboard patterns, and they want to easily just come up with a formula that they can punch however big the center square needs to be into to figure out how many blocks they need to order. Okay? So using your method that you came up with, okay, using that method, figure out what the formula is to use to make this, to find the total number of colored blocks. Okay? Go. It would 100% work. Okay? So let's go back to this one. If we did an area method, how do we know? We know that that middle square is 5 by 5, correct?
No.
For this one.
Sorry.
For this one.
Yeah.
Yep, for this one. Back in the very first one, we started with a 5 by 5 square. How did we know that the big square was 9 by 9? How do we know? No, we're still talking. How did we know that that big square was 9 by 9 way back in the first one?
There's 2 away each side.
Because the border is
2 away.
too wide, right?
Yeah, 2
The
squares.
border all the way around is too wide. So we had to add 2 on this side and add 2 on this side, right?
And
So that got us n plus 2 plus 2, which is what? N plus 2 is n plus 4, right? Okay? And that worked on this way too. So this way back here, this one right here, could have been n plus 4 squared. Right? 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 Okay?
yes,
How did we know that this number right here was 5? Because that's what the center square was, right? So this one could have been n squared, correct? And then we all said that it had to still be divided by 2, right?
I think you said there's more numbers.
I don't get just a number, right? I don't get 19. Yeah. Okay?
Okay.
With me on that one?
Yeah.
Okay, let's fast forward to this one now. Following that same pattern. So now this is our 6 by 6. Right? How wide is this one? How wide was it? It was 10, right? Because it was 6 by 6 in the middle. So that would still be n plus 4. It's still, we got to take out the 6 in the middle. And we still divide by 2, right?
Yes.
So it works on that one. So if I fast forward to this one now, how wide is my square?
N plus 2.
Which is n plus 4, right? So it's still n plus 4 quantity squared. How wide is my small one in the middle?
N squared.
N squared. So I still got to subtract that out. And I still got to divide by 2, right?
Yes.
Does that work?
Yes.
Okay. Let's go back to my method now. If I take out those corner 2 on every single one, that's always going to be that plus 8 then, right? Right? Yeah?
Yeah.
Okay. And this is always going to be n wide and n wide, right? And n wide and n wide, right? So that's always going to be 4n plus 8. Yes?
Yeah.
Okay. Which of these two formulas do you like better?
Wait, we could go. That was just the one of them.
So pink or purple? Purple. They are the same. Okay? They're the same. They're equivalent. Because we're still doing the same problem. It just is a different method of how we're doing it. Okay? Okay? So, with that being said now the construction company doesn't want to put a square in the middle. So, we just said that with the square, it was 4n plus 8. Right? Now it's not a square in the middle. Now we got to come up with a new formula. Okay? You want to do it my method or your method? Doesn't matter. Your method? Okay. All right. So your method was, how wide is this big square? No. No. It's what? It's W plus 4. How tall is this rectangle? So what is the area of that big square? Nope. Okay. Yep. Okay. Then what did we do? Or what did you do next then? Not yet. We'll get there. We can put it over there. Yeah, we can do it. We just gotta have that there yet too. Right? Because we gotta fill something else in yet, right? What else do we need to do now? So the inside is W times L? Length times width, right? Okay. And what do I do with those two on the top? I subtract them, right? And then we have to divide by 2. Everybody agree with that? Okay. That works. Let's do it my method now. My method says we take out these corner 2, we take out these corner 2, we take out these corner 2, and we take out those corner 2. How many are those? We took out 8 of them, right? Okay. My method says on this side right here then, this one would come up. So how many squares would I need to use? How many squares would I need to use? On that bottom side. How many squares on this bottom side right here would I need?
6.
Wait. 3. I'm saying 6 divided by
1.
Go back to your method. You see numbers in your method, like where we knew exactly how wide that side was.
Oh, W plus 4.
So that blue side, how many squares do I need for this blue side right here? I need how many?
W.
I need W squares right there. Okay? Which means I need how many up here?
W.
I need W up there. So how many squares total is that? 2W. Then I need to figure out this side, right? How many squares am I going to use for that side? L, which means how many squares am I going to use on this side? So all told, I need
2.
and these are also equal. Huh? Your homework for this evening is going to be out of the yellow packet, but I want to draw your attention to said yellow